We've talked about an exponential growth function, and that's when y equals ca raised to the x power. We find that our a is greater than 1. That's when we have an increase in population, or we talk about a growth function here. So this would be increase in population. If that factor, though, of a is a number between 0 and 1, your population is going to decrease. And we have an exponential decay function then. So they're still exponential functions, the variables up in the exponent. It's just dependent on what that value of a is. If it's bigger than 1, it's an increase, which means we're growing. And if it's between 0 and 1, we're decreasing, or it's a decay function. For this one then, is similar to our exponential growth function. The c value represents our initial amount, or it's also known mathematically as our y-intercept, the amount that we're starting with. A, in this case, if a is a number between 0 and 1, this is called a decay factor when x increases by 1 unit. So let's take a look at some of our examples down here to determine whether it's a growth or decay model. So I can tell what my initial amount is going to be. It's 16.5. That's my y-intercept, or my initial amount. But the number here, that 1.75 raised to the t power, as t increases by 1 unit, my value, my initial value, is going to increase. We're multiplying it by 1.75. Since that a value is greater than 1, we're looking at a growth model. As we increase our value of t, this number is bigger than 1, so our value is going to be increasing. M of t is going to be increasing. If I take a look at the next one, though, as t gets bigger and bigger, our value here, we're multiplying by 0.34 each time. So our initial amount of 7.2 is going to be multiplied by 0.34 for each value t we increase by 1 unit. And so we're now looking at a decay model. Our value of a less than 1. So for the next one, our initial value of 5, our a value is 2/3 to the t, 2/3 being a number between 0 and 1. So once again, this is a decay model. We have to be careful about this last one, though. Notice we see the number 3/4. That's a number less than 1. It's between 0 and 1. So our initial response might be that this is a decay, but take a look at the power. The power is to the negative t as opposed to positive t like the other ones had been. So to make this a positive t exponent, we have to remember what a negative exponent does. It takes the reciprocal of our base. So really this is the same as 5 times 4/3 raised to the positive t power. All right, so now when I look at my model, 5 is my initial amount, 4/3 now is my a value, and because 4/3 is greater than 1, that's about 1.3333, repeating, all right, then that's going to mean that we're talking about a growth model. Got to be careful about that exponent. Our exponents have to be positive, and to make that negative t a positive t, we had to take the reciprocal of 3/4, which is 4/3.